So, now we will study about the magnetic force. So, see here, when the charged particle is moving in magnetic field, it experiences force. So, let us see what is its formula and in what condition magnetic force acts and what is the direction of the magnetic force and in which case magnetic force does not act on the charged particle. Suppose you have taken here the axes like this is the x axis, this is here the y axis and this is here I have taken z axis. Suppose magnetic field is acting in this direction, that is here along the x axis, and charged particle is moving in xy plane like this, and when the charged particle is moving q this side here with the velocity v, and this angle is theta with the x axis or with the magnetic field. So, then this velocity has got the two components, one is here v cos theta and another one is here v sin theta. So, v cos theta is along the x axis and v sin theta is along the y axis. So, v sin theta is actually perpendicular to the magnetic field. So, force acting on the charged particle is given by here, that is this side, that is called Fm, and it is represented by Fm is equal to q into v cross b, or we can write here magnitude of the force Fm is equal to q b into v sin theta. It means perpendicular component of the velocity in the magnetic field is responsible for the magnetic force. So, the direction of magnetic force can be given here by using the right hand screw rule. Suppose if you are placing your palm like this is here along the velocity and folding it towards the magnetic field, the thumb is pointing upward, then the thumb is the direction of the magnetic field. And also in this case magnetic force is here perpendicular to the plane of the velocity and this is your magnetic field. So, magnetic force is always perpendicular to the velocity and magnetic field. And see here, due to v cos theta there is no magnetic force on the charged particle. So, let us study here the different cases in this case. Suppose you have taken magnetic force Fm is equal to qvb sin theta. This is the formula for the magnetic force, and the magnetic field is acting this side and charged particle q is moving with velocity to this side. It means theta is equal to 0. If you have taken theta equal to 0, magnetic force is equal to 0. So, when the charged particle moves in magnetic field parallel or anti-parallel, because we can take theta 0 or 180 degree, in both the cases magnetic force is 0. Suppose if you are taking theta is equal to 90 degree, then you will be getting Fm is equal to qvb, and this is called maximum magnetic force. So, when the charged particle moves perpendicular to the magnetic field, magnetic force is maximum. Now, if you are taking here the velocity is equal to 0, that means the charged particle is at rest in magnetic field. If the charged particle is at rest in magnetic field, then also the magnetic force is equal to 0. It means the charged particle which is at rest in magnetic field does not experience any magnetic force. And also if in place of the q is also 0, it means in place of the any charged particle you are taking any neutral particle, then also magnetic force will not be acting on the particle here. So, these are the different cases where the magnetic force acts on the charged particle or where the magnetic force does not act on the charged particle. So, now see here Lorentz force. So, we have seen the magnetic force acting on the charged particle. So, now see here when the charged particle having charge q moves in a magnetic field and electric field both having velocity v. So, when the charged particle is moving in both electric and magnetic field with velocity v, then the total force acting on the charged particle can be given F is equal to Fe plus Fm. So, Fe is called electrostatic force, Fm is called magnetic force. So, we can also write F is equal to Qe, that is the direction of electric field, plus Q into here V cross B. So, this total force F acting on the charged particle is known as Lorentz force. It means when the charged particle is moving in electric and magnetic field both, it experiences this much force, and this force is known as Lorentz force.